So yeah, my name is Chris Buithaert. I'm going to talk about a bunch of horror stories I had to live through the past 7 years. Works better if I turn it on. You might already have seen this slide. Decades ago, I was a software developer. Wrote stuff in all kind of crappy languages, PHP, Java, C. They tend to become popular again. And then I became an ops guy, and I've been doing a lot of stuff. I'm one of the guys who started organizing DevOps days in Ghent 5 years ago. Time is flying when you have fun. And what I'm doing mostly is today, as Inuit is an open source consulting company in Europe, we help organizations deliver software faster with open source. So when I was working on this talk, I was figuring out, is it really 7 years? So I'll log into one of our boxes, and yeah, it was 7 years. And I was actually hoping to say that this box is down now, but it's still up and running. So that's yet another horror story. The reason I'm giving this talk is that there are so many things you need to look into when you're deploying an infrastructure. And sometimes their problems are really hidden somewhere in a corner where you really don't expect it. And documenting these for you guys, maybe one day you'll figure out, oh, I need to test this too. But there's already a large list of things which you need to look at when you're debugging problems. This is my debugging list, which I wrote somewhere in January 2006. And as a lot of you know, my mantra is everything's a fucking DNS problem, because that's what usually all the problems are. And that's the first thing I start looking at. ARP problems, disks that are full, spanning tree if it's in networking. We had USB problems with different ports not working, all that kind of stuff, but most often when things start breaking, it's a DNS problem. So, let's go to the first story. If you start doing Puppet, the first thing you need to do is deploy a Puppet master. So when you start building an infrastructure, we had this customer where what the product they were shipping was basically a rack full of equipment, some custom equipment, some off-the-shelf equipment, and everything in there was redundant. One of the boxes there was PXE boot server, Yum repository server, Puppet master, and all the stuff. And basically reinstalling the platform meant that you scratched that primary node, and then you scratched all the other boxes, and they just redeployed. That's how stuff works. And, well, that works in development, worked at the customer site, and then they shipped the platform to a different continent. And the final test before production is, let's scratch it again and see if everything continues working. And obviously, that's when things go wrong. So you're on a remote location, you don't have access fully to the platform, and suddenly it doesn't work anymore. Because you just rebooted that very first machine, and you boot up the first node, a couple of nodes come up, a couple of others start failing, and you're like, what's this? The code works. Sometimes it works, sometimes it doesn't. So you start stripping out manifests, editing things where they're just minimal notify, and you enable code more and more, and you run the server in debug mode, and the problem gets worse. And then it works again. So we consider renaming the box to Schrödinger rather than the actual host name. How much time do you spend debugging on such a thing? Well, a lot. And obviously, Murphy kicks in the middle. The setup was in Saudi Arabia, and obviously, VPN goes down. So what really happened was we had basically a problem with a managed power supply. Usually, what we do when we scratch the platform is we tell the managed power supply, power of everything, power on the one machine. When that machine is powered on and bootstrapped, then you can power on all the others. And that's what we thought we did. We assumed that all the physical machines were down. They weren't, because the power supply was broken. heat, temperature, Middle East country, you don't know. And what happens then is that there's a new puppet master with a new CA, and it was an old setup. I mean, these are stories from 7 years ago. And with about 6 to 8 nodes trying to knock to Webbrick, it was just breaking. But before we figured out that the actual nodes were running, that was a long time. And it was not a DNS problem. So that was my first story. So there's 7 of these. Might get boring. Who loves monitoring? That's a big chunk of you. Who thinks monitoring still sucks? So we, like a lot of others at this customer, run a Chinga. And it works perfectly. Till at a certain point, it starts breaking. Frequently, unfrequently, it's happening. And the setup we're using it's a trivial one. The standard use of stored configs. Does everybody understand stored configs? Who doesn't understand stored configs? Okay, then I can skip this. Trivial. You export resources, you collect them, and it works, generally. You have an Akinga server, it collects all your hosts, it connects all your services, and it starts building a config. And we figure out it doesn't. It's not broken, because Puppet runs are successful. Akinga is working perfectly. It's reconfiguring itself, it takes in all the resources, but the disk usage grows and grows, and we try figuring out why. Who knows why? Does anybody know the concept of file buckets? Just one person laughing. So basically there's this thing in Puppet which allows you to take a backup of the file you're changing, and in case you need to revert, you can use that. And usually it works, it cleans up after itself, and you don't see any problems. Up till the point where you actually hit some bugs. And Puppet seems to have issues with actually parsing correct Akinga code. Can you guys read that? Because to me the font is fuzzy. This is an actual bug in Puppet which we ran into, where if you don't define a parent in your Nagios host, it fails. And it starts filling that file bucket fast. And because you have a lot of resources, because you have a lot of files there, it breaks. It took us about 3 weeks to figure out what the actual root issue was. But once you find that out, it's pretty much just adding that parent parameter and stuff starts working again. So yeah, finding those is not trivial. Who thinks release management is a solved problem? Sam, you really think it's a solved problem? Okay, are you talking about it? Maybe next year, okay. I want to see that talk. Come and give it at config management camp. So software release management is a problem we all have to deal with. One of the setups where you see it mostly is how do you know which software to deploy, which version? So we ran into a case where we have a lot of customers running a similar stack, but they're all slightly different. And at one Monday morning, we get calls from a bunch of customers who say, well, it stops working. We have a new release, and actually it was mCollective, but just new release. And for about half of our customers, everything continued working. And another bunch, it stopped working. Why? NTP. That could have been. It was not NTP. It was also not Rabbit. Was there another ID? DNS. It was not DNS. It was basically people who used their own repositories who did not get the automatic upgrade. They were perfectly happy because they were not pulling in random stuff from the internet. But all the people that were just using upstream Yum repositories and downloaded anything which was from the internet, they were in pain. Because if you ensure latest, when latest evolve and you don't have that in your test environment, it's broken. So one of the ways we try to solve that is to actually have every piece of software which you deploy in a production platform on a local mirror. And in an RPM world, we use a tool like Pulp to do that. It's really easy to set up mirroring, but it's not the best tool. It's sometimes unstable. We don't really like a bunch of the tooling that is used in the back, like Mongo. There's no support for Debian, and some people actually try to use it as a Puppet Forge, which is really not something we like. But there's other tools around. PRM is one. We're also looking at Yum Repo Server from the Mobility Scout guys. And the point is that we figured out now a pattern on how to stop platforms from breaking that way. What we do is, on one side, you have the internet. And this is an example of an actual customer setup. It's using CentOS, but you can do the same with different software distributions. And what they do is, the internet is going to change. The internet is not going to be reachable when you most need it. You're going to be deploying from remote locations and stuff like that. So what you do is you mirror everything you need to build your infrastructure. The whole CentOS tree, everything you need. Then you need to mirror all the upstream repositories you're downloading stuff from. EPEL, gpackage, Puppet Labs repositories. And then there's obviously, because you're building a software product for your customers, the own software you built, or software which you slightly repackage because the dependencies are not what you like. And those you cherry pick into your own repositories. And then you can actually use Pulp to mirror clones. And one of the big advantages there is that Pulp does not copy files on disk every single time. It has its own system, so the file is not going to be, even though I have 4 times the same repository online, it's not going to be 4 times on disk. And then you can actually point your environments, your production development or user acceptance platforms to the right repositories and promote packages that way. And if you're doing that, there's absolutely no issue in using latest in your modules, because you know that you control the repositories. You know which package is going to be latest. So you can do that without any problem. But if you don't control those repositories, using latest is pretty much committing suicide, because you don't know when the upstream vendor is going to change the version of the package. So that Monday morning, we actually explained to a bunch of customers that what we told them before, they really needed to use their own local mirrors and their own local repositories. And they won't feel the same pain anymore. So that's part of what we need to do. We need to teach our users. We need to teach people, because we're all developers now. We are all needing to learn new tools, new platforms, new languages. So that brings me to yet another customer story. One Monday morning, right before I had to jump on a plane, obviously, they called me and said, well, we don't have any Puppet runs anymore. We see that since a couple of hours, there's nothing in Puppet dashboards anymore. Puppet runs don't show up. But we see that the job, the cron job, is still running. It still shows up. It still works. But dashboard doesn't show anything successful for weeks, for hours. So you go into a box, you log onto it manually and say Puppet -t. It comes back, there's no error, and the exit code is correct. So what's this? Any ideas? What? I can't hear you. Can you speak up? A full disk. Yeah, that was one of the things we figured. It wasn't a full disk. So when you run into that, you start looking into your code. You quickly do a git log of what's supposed to be on that machine, and you notice there's no real changes in the code base which could apply to the nodes that aren't running. So let's put the agent in debug. You see a couple of lines popping up, and then nothing. And you put the master in debug, and you see it perfectly builds the catalog, ships it. Like, okay. So what's going on? It's the code, you think. Let's try this in a different environment. Different Puppet environments have different code bases, and we figured out it kind of worked in one environment. So, do we need to upgrade the Puppet Master? How many times is upgrading a good solution? Never. Yeah. That's what I tried explaining to my customer, but given that I was about to jump on a plane, they said, well, we'll upgrade it. That didn't solve anything. So, they upgraded Puppet Master, they upgraded the agent. That didn't work. What else should it be? DNS. Yeah. It wasn't DNS. Could have been NTP, could have been SSL. So we clean out the SSL certificates, we reissue them all again, and still doesn't work. So that's when I've got a team, and they've seen more than I've seen, and as a collective, you have more experience together, so that's when we put in a task force and like, hey guys, can everybody have a look at the platform and dig in? And nobody had seen something like that before. So it was really a broken setup. We really could not fix this. So what is the next step you do is you start looking into the code again. And when you do that, you focus on the machines where you think the code you should be writing is actually being parsed. And we did not see any changes that could introduce the change. And it was pretty much all the machines were failing. And 90% of the platform was Linux. And there was 5% of the platform using Windows. So we just ignored the code that was written on Windows because Windows code wouldn't break Linux platform, right? That's what I thought. And then we found this little gem. So it says, this is the diff from GitHub, require no Kogeri, and then exit 0 unless factor.value OS family is Windows. I'm not a Ruby hacker, so we needed to dig into the code and figure out what that does. It does the exit 0 first, and then the unless. So it was behaving exactly like expected. And it was the fact included on all the nodes. The guy that wrote that code now has an email address, exit0@customer. It's something you really, even if it's code which is not running on your machine, it can actually break stuff. And nicknames can be acquired by writing code. Software-defined networking, that's a new hot thing, right? Well, it's not really about software-defined networking, but I needed a title. So we have another customer, we have a bunch of customers, and lots of them are running Puppet. And one of the platforms we built for them pretty much is, again, a stack of machines, pretty static, and it's being deployed over and over again, and they have a couple of different production instances of that. And from the central Puppet master, from the central monitoring setup, there is pretty much, does this work? Doesn't work. So top left is one data center. There's a Puppet master. There's the monitoring setup. There's a bunch of peripheral data. Down left is the other data center where the actual jump host is from where most people log onto the platform. And then on the right, there's two, three different customer platforms. So stuff works. And we are deploying a new platform for that customer. And suddenly that morning, Puppet Run starts failing. We can, from the jump host, perfectly access the customer platform. Monitoring says everything is OK. I can check all the nodes, all the IPsec tunnels are up, we can ping the Puppet master can ping the boxes, everything is fine. But Puppet Run starts failing. So we think it's a DNS problem. And indeed, it was a DNS problem. The reverse DNS was broken. Lookups didn't work, HTTP timeouts, and so let's fix this. 10 minutes later, it's not a DNS problem, because it's still there. We improved the situation, but we didn't really fix it yet. So SSL, NTP, the usual setup, the usual figuring out what the hell was going on. And we figured out, well, let's debug this completely. I can ping the Puppet master, I can connect to the right ports, the Puppet master, it all works. I can do wget, oh no, I cannot do a wget. Let's TCP dump this. Hey, why does it say a response I can telnet to the port, but why not? It must be networking. But every single connectivity is up, monitoring says everything is working. And I can actually log on to the box, but from the jump host. And I could also log on to the box from the monitoring service. So the actual culprit there was that the IPsec setup was broken. The customer side had reinitiated, for some reason, the IPsec connection on different ports. The netting was broken, and restarting solved everything. It had nothing to do with Puppet. But if you have had setups that were breaking because of exit zero code, this is one of the things where you go figuring out what's going on again. So right, seventh one. You know, there's three hard things in IT. That's cache invalidation, shared memory management, shared memory migration, and that kind of stuff, and naming things. And naming things is really difficult. How many times have you seen one like this? For a couple of you, this is really familiar. You've got an imported resource which is already defined and blah, blah, blah. But how can this be already defined? We don't export that resource to that host. It should work. So how do you debug that? You dig into PuppetDB. You go figure out what's actually in the database. And you see what's in there. And then you realize that there are a bunch of things in that database which are actually double. So Apache vhosts. And we use tags to collect the data. Every single vhost was being exported with a tag proxy because the reverse proxy needed to collect these. Does anybody see the problem coming? This was the profile that was used to collect the vhosts. The solution is already on there. But basically what Puppet does is it does automatic tagging of every single part of the namespace. So proxy was something it got multiple times from nodes. And we didn't explicitly export it, but Puppet really did. So if you name your profiles proxy and you collect proxy, you're being screwed. And that only came into place the moment we refactored that customer to profiles, because before that, it was never profiles vhost proxy. So there is a bunch of lessons we learned, and we really need to share those with people. First of all, for me, repository management is something really, really important. If I cannot reproduce an infrastructure exactly the same way I designed it, then my setup is broken. The second thing is that if you are writing Puppet code, you also need to take into account the best practices the developers use. You really need to have a development Puppet master where you push the code to first, so it cannot break the rest of your platforms. Specifically, if you have new people joining the team who are .NET programmers who now start writing Ruby code. Monitoring is something which you never do enough. We were monitoring if all our tunnels were up and the number of tunnels between our data centers were up and running. We were not actually monitoring if we get traffic over those tunnels and what kind of traffic we could get over the tunnels. So that's an additional check we needed to build in. Like you already knew, upgrading is definitely not the right way to solve problems, unless, of course, the bug you just ran into has been fixed. And release management is, to me, still one of the biggest challenges we need to solve as a community of infrastructure people. We still need to find good tools and work on good tools to actually make sure that we know what software is deployed where. And Puppet is helping us there, but it's still not a solved problem, except if Sam knows how. Hmm? Yeah. Okay, so that was pretty much my talk for today. Still have some time, so I want guys to introduce you all to one of the things I've been organizing. This is Config Management Camp. The day after Config Management Camp, there's going to be a Puppet Contribution Summit, and it's going to be in Ghent right after FOSDEM, so you all need to come to Brussels and Ghent for this. That was pretty much what I wanted to give to you. Any questions? No questions. I hope that at least one of the issues I just explained is going to gain you some time in the next couple of months, because then it's all been worth it. Okay, thanks.